Hello again. Today's lesson is going to be an introduction to trigonometry. This might be a review for some of you, depending on what course you're at. So the first thing we should always review with trigonometry is right angle triangle trigonometry, and we start with the Pythagorean theorem. So the Pythagorean theorem was developed in order to find the side length of a right angle triangle as long as two other side lengths are known. Now this does require you to know that we always label the hypotenuse as c, and the formula for the Pythagorean theorem is a squared plus b squared equals c squared. Now I'm actually starting with one of the more difficult examples just to show you a very common mistake that people make when solving these kinds of triangles. The biggest mistake that's made is that thinking that if you're given two numbers, that those two numbers always go where the a and b are. And that is not the case. Here, the c, or the hypotenuse, is given to you, and you must put the hypotenuse in the c position. So what the equation would look like if you substituted the numbers in would be like this. And that means that there's a second step to do. We actually have to isolate a squared to be able to find what a is. So a squared plus b squared equals c squared is the Pythagorean theorem, but you have to always know where the numbers go. If your hypotenuse is given, you have to put the hypotenuse in the c position. If we want to isolate a squared, that means we have to move the plus 3 squared over to the other side. So that's going to look like this. And at this point, you have to follow BEDMAS. You cannot do 10 minus 3, which I've seen many students do over the years. You have to do 10 squared minus 3 squared, which would be 100 minus 9. And I'm going to show all the steps here. You could definitely skip some steps, especially if you had a calculator here. You could literally just do 10 squared minus 3 squared on your calculator. This will give 91. And then to finally find your final answer, we have to destroy the square. And the function that destroys a square is the square root. So we're going to square root both sides, which is essentially just going to be square rooting 91, as the square root of a squared is just a. And then we would use our calculator to calculate the square root of 91 if we need the decimal value for the answer. And that gives, on my calculator, approximately 9.5. So I'm going to round it off to 9.5. And that's the Pythagorean theorem when you're looking for the hypotenuse. It's a slightly more difficult one than this next example. In this case, again, you're given two side lengths and a right angle triangle. That's what tells you need to use the Pythagorean theorem, especially since we're looking for a third side. So a squared plus b squared equals c squared. Now we can write this equation as c squared is equal to a squared plus b squared. It doesn't matter which order you put it in. And it's actually better to use the second version here, since the c squared will already be isolated on the left. We will have to get rid of the square, but the c is on the left. So substituting our numbers in for a squared and b squared, we get 50 squared plus 20 squared. So c squared is equal to what? Well, I'm just going to do this on my calculator off to the side. 50 squared plus 20 squared gives 2,900. And our final step is to square root both sides to isolate c, and I'm going to let you fill this in. Alright, square root of 2,900 you can do on your calculator and just find the final answer. And that's pretty much all you need to know about the Pythagorean theorem. But what happens if they don't give you two side lengths? What happens if they give you an angle and a side length? If you're given an angle and a side length, you're going to be using what we call Sohcahtoa as an acronym to remind you of what the formulas are to use. Now, I'll get back to Sohcahtoa in a minute. There's a few things we have to cover before we do that. And the first thing that I wrote in red here is please make sure your calculators are set in degree or DEG or D mode, which is degree mode, before you start doing these kinds of calculations. If they are not set in the proper mode, you will get the wrong answer for each question. So make sure of that. Also, it's important to properly label the triangles. So, and I just wrote up here, by the way, that it's when do we use Sohcahtoa? We use it when an angle and a side are given and we're looking for other information. So I'm just restating what I had already stated. But it is important to properly label the triangles. If you are given an angle, there are 3 sides that you have to label from that angle, but only 2 sides that are going to be worked with. I'm going to label all 3 sides right now, but when we get into the actual problems, you'll see that I'm only going to be labeling the 2 sides that we're working with. So how do you know which side's the opposite? How do you know which side's the adjacent? And how do you know which side's the hypotenuse? Well, the easiest of those 3 is the hypotenuse. The hypotenuse is the longest side. It's also across from the 90-degree angle. All right? So, but usually we just state that it's the longest side. For the opposite, which is the second easiest side to find, and it's always based on the angle. By the way, I should probably mention, what is this symbol? If you have never seen this symbol before, this is the angle symbol called theta. It's a Greek letter that is commonly used to represent angles in mathematics. And it's just because we ran out of the normal alphabet letters, we had to go to the Greek alphabet to start labeling different things in math. So getting back to the opposite side, the opposite is always labeled based on the angle, and so is the adjacent. The hypotenuse, like we said, is the longest side. The opposite side, if I draw a dotted line going right down through the middle of the triangle, that side is the side that's opposite from the angle. That's what opposite means. If you're opposite the room from somebody else, they're across the room from you. So therefore, that is the opposite side. I like to use OPP for opposite, just because if I use an O, some students think that's a 0. And the last side is the adjacent side. Now, adjacent, the word adjacent means next to, all right? So which side is next to the angle, touching the angle? Well, we actually have 2 sides touching the angle. We have the hypotenuse touching the angle up here, or forming the angle, if you will, and we have this other side forming the angle. Those are the only 2 sides that are touching the angle. The opposite side doesn't form the angle, it doesn't even touch the angle, it's way across here. So one of these 2 sides is always going to be the adjacent. Well, it's the one that's not the hypotenuse. So the adjacent side is here, and I'll just write that the word adjacent means next to, so hopefully you'll remember how that works. Now this is always based on theta. The hypotenuse is the only one that we don't need to know theta for. All right, so let's look at one more example just to reinforce this idea, because if you get this wrong, unfortunately the entire question will be wrong. So it's really important to label the triangle properly, and I probably should write the word triangle properly. There we go. So which side is the hypotenuse? That's easy, it's the longest side. Which side is the opposite? Well, we've got 2 sides left. Which one is across the triangle from the angle? That's the opposite side. And which other side is touching the angle, forming the angle with the hypotenuse? It's this side here, which is the adjacent. And the reason we need to know that is because of Sohcahtoa. Now, I write Sohcahtoa a little bit differently than textbooks do. I don't like writing it the way they do because, and I'll explain in a second, usually textbooks write Sohcahtoa this way. And I've had some students think that that means that everything is multiplying. Alright, Sohcahtoa is a division, and it stands for the sine of the angle is equal to the opposite side over the hypotenuse. The cosine of the angle is equal to the adjacent over the hypotenuse. And the tan of the angle, the tangent of the angle, is equal to the opposite over the adjacent. And these formulas, I'm not going to get into too much where they come from, but basically, if you take 1,000 million 30-degree angle right angle triangles and you divide the opposite side length by the hypotenuse side length, you will get the same length for all of them. So mathematicians discovered that no matter what the angle is, if you have a 60-degree angle triangle that's big or a 60-degree angle triangle that's small, if they're both right angle triangles, dividing the opposite by the hypotenuse will always give you the same value. And it's a ratio. It's a division, a fraction. So because you're dividing by the hypotenuse, by the way, that fraction always has to be between 0 and 1. So because this number is going to be smaller than this one, if you divide a small number by a big number, you always get 0 point something as an answer. And that's going to be true for the cosine as well. The cosine is the adjacent divided by the hypotenuse. So every 60-degree angle right angle triangle, when you divide the adjacent divided by the hypotenuse, you always get the same answer. Now tangent's a little bit different. This one you can actually have a number greater than 1 when you do the opposite divided by the adjacent, because if the opposite side is bigger than the adjacent, then you will get a number bigger than 1. But you can also have the reverse. But for the cosine and the sine, you're always going to be expecting to get small decimal numbers when you divide the opposite by the hypotenuse or the adjacent by the hypotenuse. Decimal numbers smaller than 1. And the reason we need to know Sohcahtoa is because based on which two sides are given to you in the triangle, you have to pick the correct ratio to use to solve that problem. And this will be much easier to show with an example. So let's say you wanted to measure the height of a tree, and you stand 4 feet away from the tree. You don't have any way of measuring the height by climbing the tree, but there are tools now on cell phones that are able to measure angles when you tilt your head back. So let's say you're able to measure that this is a 43-degree angle, and we're going to assume that you're laying down on the ground to do this. It might not be comfortable, but just to make things a little bit easier here. So if I draw that right angle triangle without the tree, this is not easy to do. We have 43 degrees here, and we have 4 feet here. Which two sides are we talking about? If I ask you to calculate the height of the tree, the height of the tree is this side here. Is that the opposite, adjacent, or hypotenuse? We need to know that. So the height of the tree, if you look at it, is across the triangle from the angle, and it's the angle that we're talking about, never the 90-degree angle. Okay, so the 43 degrees is the one that was given to us. This is the opposite side. The 4 feet is which side? Well, that is the one that's forming a side with the hypotenuse to give the angle, right? So that is the adjacent side. And I know that the other one's the hypotenuse because it's the longest side. So with opposite and adjacent, if we go back a slide to Sohcahtoa, which of these three relationships has opposite and adjacent to it? It is the tangent. So this is the equation we have to use. If you used one of the other two equations, you'd actually get the wrong answer. So that's why it's so important to label your triangles properly. You need to be able to pick the correct ratio. So tan theta, this is a TOA scenario. Therefore, tan theta is equal to opposite over adjacent. And now I can actually start putting my numbers in to be able to solve this question. So if I look, theta is given to me, that's my angle of 43 degrees. Equals my opposite side, which is, I don't know my opposite side, so let's label it as x. We usually use x for unknowns, right? Divided by my adjacent side, which I do know, which is 4. And now I'm going to isolate for my x, and my calculator will do the rest of the work for me. So, and because this is a grade, I'm teaching this lesson here for a grade 11 class, we're going to do this without doing tan 43 right away. We're going to isolate the variable first, which is actually more powerful anyway. It's a more efficient way of doing it. So if I want to get x all by itself, I've got to get rid of the 4. The 4 is dividing. If I want to get rid of something that's dividing, I move it over to the other side and I multiply. So that 4 is going to go over here and multiply the tan 43. Now, folks, this is not a multiplication. It's a really hard thing for students to get used to. Tan 43 is a function that has swallowed a number, and your calculator is going to spit out the answer. Okay, you can't think of this as a multiplication even though they're side by side. These aren't variables. All right, so please be careful with that. I have seen some students write tan times 43 on the calculator, and unfortunately some calculators will actually give you an answer when you do that. This is not tan times 43. So I'm going to show you on the calculator that I have how I would input that. So I'm just going to transition over to the calculator here. So first thing I'm going to check on this calculator is whether it's in degrees or not. It is, and you can tell because of this little DEG here. Okay, if I click on that, it's actually going to change to RAD, and if I click on it again, it's going to change to GRAD. We need it to be in DEG, and on normal calculators, that's usually shown in the window of the calculator somewhere. Either there'll be a D or there'll be a DEG. Now, I'm just going to clear this stuff out here so there's nothing in our way. Okay, so this is an older style calculator that requires you to put the number for the angle in before you put the tan, sine, or cos. Most newer calculators, you can do it exactly as it was written in the question that we just did, which is 4 times, and then you press tan and then 43. But on this calculator, I have to do 4 times 43 and then go find tan, which is in this trigonometry menu here. And what the calculator has done is, I hope you can see this, it's a little bit small, but it's actually put the 43 inside of the tan, which is where I need it to be. And then when I press equals, it says 3.73. So we're going to round that off to 3.7. Let me transition back to the note here. So our x value is 3.7. Now we should technically write it like this at the very end, which you could have done on this line here. You should always isolate your variables on the left in the very end of the question. So, and because this is a word problem, the height, we should have a sentence, is 3.7. I believe that was, oh, it was in feet, not in meters, sorry. And there you go. We've now calculated the height of that tree. Here's another question. I'll read through the idea here. So let's say you are standing right here on the side of a river, and you wanted to know how wide that river was. You have to cross it or whatever, and you want to know how wide that river is, but you can't get across it. You don't have a boat, you can't swim, it's too cold, whatever. You still need to know how wide that river is. Well, if you had some sort of landmark, like a branch, and you could measure how far away you were from that branch on the same side that you are standing on the river. Okay, so let's say this is the beach. You're standing on that side of the river, so you're going to walk 40 feet, you're going to measure off that distance. And let's say you use that tool again on your cell phone to measure angles. All right? Well, that's all the information I need to be able to calculate the distance across that river. Now you'd want to make sure that this branch is directly across another landmark, so I put a tree on the other side so that we could line it up as closely as possible. Now this would be an estimate, obviously, but it could be a pretty good estimate. So I've already labeled the two sides from the 52-degree angle. This is my opposite side because I'm going across the triangle to find it. This is my adjacent side because it's right next to the angle and it's not the hypotenuse. So opposite and adjacent is tan. Tangent of 52 degrees is equal to my opposite, which I don't know, over my adjacent, which is 40 feet. And now again, I'm just going to isolate x by doing 40 times tan 52. And this time I'm going to let you do that on your calculator to come up with the final answer. Now it's not always going to be tan. I know the previous one was a tan example as well. That's not always going to be the case. Just a coincidence that it was. Let's look at another example. Now in this example it's asking you to solve the triangle, which means find all of the unknowns. Now what's nice about this is if I asked you what is this angle, now because this 22 here is my theta, I'm going to call this alpha, which is another Greek letter that you can use. Okay. Now alpha is easy to calculate because all three angles in a triangle always add up to what number? All three angles in a triangle always add up to 180 degrees. So if we subtract 22 and we subtract 90, we're going to get what our alpha value is. And I'll just do that off to the side on my calculator here. And that's giving me 68 degrees, which I probably could have done in my head if I thought about it. So we already know the alpha value, so we don't know the x value here, we don't know this side value here. Let's find the x value first. Now I want you to notice that the x value is actually my hypotenuse length, right? So if we label this triangle, we've got hypotenuse here. Which side is given to me from my angle? It's my opposite. So, no pun intended, we're going to be using SO. This is a SOH scenario, all right? Therefore, we're going to write sine 22 is equal to my opposite side, which is 15, over my hypotenuse, which is x. Now, I did this on purpose. A lot of students will always think, oh, my x always has to be on top. No, that's not the case. Sometimes the x is going to be on the bottom. If your unknown is the hypotenuse in Sohcahtoa, for So and Ka, then you're always going to end up with an x on the bottom if you're looking for your hypotenuse. So we have to discuss this scenario just in case it happens. How do you isolate a variable if it's on the bottom of a fraction? Well, you have to do a two-step process here, which eventually, if you understand this two-step process, you can simplify to one step. The x on the bottom of a fraction is the worst position for the x to be in. So let's get it out of there. If it's dividing on this side, what does it do on this side? So what we're going to do is we're going to move that x over to this side beside the sine 22. And the only thing left on this side is the 15. So notice I did not move the 15. The 15 is not the problem. The x is the problem. So whenever x is on the bottom of a fraction, you move it over to the other side. And now we're going to take the sine 22 and get rid of it. Well, it's... Okay, so let me be clear here. Sine and 22 aren't multiplying each other. But all of sine 22 is multiplying x. So to get rid of a multiplication, we're going to divide by sine 22. And here's the trick. This x and this sine 22 just switched places. So you don't have to write this step if you can remember that whenever your x is on the bottom in a trig for right angle triangle problem, you just exchange it with the sine 22 or the cos 22 that's on the other side. or potentially the tan 22 if it was a tan scenario. So this would be 15 divided by sine 22, which I'm going to do on my calculator. So 15 divided by sine 22, and I have to press equals on my calculator to get the correct answer, which is 40, and I can't remember if it was feet or meters here. So this one's in centimeters, so that's 40 centimeters. Okay, so we now know that this side here is 40 centimeters, and our hypotenuse should be longer than this side, so that kind of makes sense. So now I know, I'm just going to redraw the triangle quickly here. This is 15, this is 40, this is 22, right? We now need to find this side. Because I'm solving the triangle, I'm trying to find all the unknowns. I already found the angle. What would be the best equation to use to find the question mark? Well, there's two ways of thinking about this. I could definitely use the Pythagorean theorem now because I have two side lengths. But the problem is one of the side lengths is a calculated value. So if you made a mistake with calculating the 40, by calculating the question mark side, you're now going to use that mistake to calculate a new value, which is just going to propagate that mistake throughout the rest of the question. So it might actually be better to go back to trigonometry to calculate the question mark. However, most teachers and most textbooks will allow you to use the Pythagorean theorem. Okay, so I'm going to write either use Pythagorean theorem or another trig ratio to calculate the other side. I personally would rather use the trig ratio because I'd be using the 22 and the 15 instead of the 40, which I just calculated. So what two sides am I working with if I'm working with the 15? Well, the 15 is the opposite, and the question mark, well, the question mark is the adjacent. Okay, so I'm using opposite and adjacent here. Opposite and adjacent is tan. So I would write tan 22 is equal to 15 over, now I've already used x to represent the hypotenuse. So I'm going to use y to represent this side. So it's going to be 15 over y. And we're going to do the same thing we just did before, but I'm going to do it a lot faster. So like I said, if your variable is on the bottom of the fraction, exchange it with the tan 22 on the other side. So you're going to get y is equal to 15 over tan 22. And I'm going to let you calculate that value. And that's it for today's lesson. So, as a bit of a summary, if you've got two side lengths in a right angle triangle and you're looking for a third side length, you use the Pythagorean theorem. If you're given an angle in a side length, you're going to use Sohcahtoa to figure out which of the three ratios you should be using by labeling your triangle properly. Once you've found the correct ratio, you just plug in your numbers, and sometimes you might have to isolate the variable if the variable is on the bottom of the fraction. So expect some work in the Google Classroom, folks, for those of you following along in the Google Classroom, and we'll talk to you in the next lesson.